This is a demonstration walkthrough of Lab 27.2.13, Interpret HTTP and DNS data to isolate a threat actor. In this lab, you get to investigate an SQL injection attack and also investigate DNS data exfiltration, where data is stolen from the network using the DNS protocol. To do this lab, you're going to need the Security Onion virtual machine that comes with the Cisco Networking Academy CyberOps course, and you're going to need to install that virtual machine in VirtualBox. You can see here that I've already logged into Security Onion using the username analyst and the password CyberOps, and I'm ready to do this lab. Now, the first thing you need to do in this lab, following the instructions, is we're going to open up a terminal and make sure that our tools that are built into Security Onion are running correctly, our sensors. So we'll put in a sudo so status command, put in the password CyberOps, and you can see that the Squeal server is running. We have the PCAP agent, the Snort intrusion detection system, and there is the Elastic Stack, Elasticsearch, Logstash, Kibana. So in this lab, the main tool that we're going to use in part one is Kibana. And Kibana is part of the Elastic Stack, and it's the browser-based interface for searching, analyzing, and visualizing your log and alert data. So I will double-click on Kibana and open it up. I'll put in the username analyst and the password CyberOps. It'll take a second, but we should get the Kibana dashboard. Now, Security Onion has configured Kibana with all of these pre-made visualizations and dashboards to help you investigate network attacks, alerts, and events on your network. And you can see here that this is the basic dashboard, and we have 0 logs, no events. This is just showing the last 24 hours. In this lab, we're going to have to set the date range that we're looking at for investigating this attack. So I'll click on last 24 hours, and I'll set an absolute date range from June 1st to June 30th and click OK. It'll take a second, but we should see some events. Okay, we've got 136 logs. You can see here's the basic time that this is happening on our count over time, event count over time. You can see the count here, 52 events here, 26 and 58. What we're going to do is a SQL injection attack usually takes place by attacking a web application over the web through a website that has a SQL server, database server on the back end. So to do this, let's isolate for this time period. Let's look at just the HTTP events. So we can go over here, and these are all dashboards. And this is Zeek hunting dashboards, which are part of the what used to be called the Bro intrusion detection system. I'm going to click on HTTP, and it'll give us a dashboard that focuses on HTTP events. You can see there's 22 HTTP logs. There's the log count over time. We can see a little dot right there. That's the count, 22 events. Now, if we scroll down here, we can see that the country, here's the port 80. You can see that the status message was OK. These were GET requests that had OK status 200 code, and it happened 22 times. And you can see the source IP address here, the destination IP address. This is the server that was being communicated to. The MIME types, these are the files that we were dealing with. You can see it was HTML, JPEG, PNGs, GIFs. The HTTP site, this is the server that we were contacting. And I'm going to keep scrolling down. You can see the URIs that we were reaching. These are the website and the different resources on the website. And then if we scroll all the way down, we see here the HTTP refer, Once again, these are the sites that we were looking at. Look at this URI right here. And I'll scroll all the way down to the bottom to see the HTTP logs. So this is the first 10 logs. And if we look at this first log, we can see the timestamp right here for the first log for this event. The source IP address, the destination IP address, the destination port. If we open this up, we can get some more information about this first log event. So here is the alert ID right here. We can see some more information. The destination GeoIP address was in the United States, the IP address of the server. We can see the event type is Bro HTTP. Once again, Bro is the name of the intrusion detection system that's before the name change to Zeek. The destination port, and if we scroll down a little farther here, we can see the message. And in the message, we can actually see here that the request, the URI, which the lab asks us to look at, that they were going to a page called Mutilidae, and there's a PHP, and then you can see that the URI request, you can see user info, PHP username, and you can see here union plus select plus CCID. This is short for credit card ID, credit card number, the CCV, expiration. So these are the fields from the database that were being pulled in this SQL injection attack. So you can see it right there. Now, if we want to take a look at this information, what we can do is we can take a look at this by looking at the packet capture, the information from the packet capture. All we have to do is click on the alert ID, which you can see here or here. And if I click on that alert ID, it will open up the PCAP, or the packet capture, in CapMe. And here I have access to the PCAP. Now you can see on this link right here, this is a link to the actual PCAP file, which we could open up in Wireshark if we want. But using CapMe here, I can see the transcript of the session, of the conversation. So right here at the top, we can see the log entry, some metadata about this entry. Then here in blue is the source request from the user that will reveal the data from the database. Notice the SQL injection query, which is basically formatting the query and putting in a union select credit card ID, credit card number. This is the query into the query that probably should not have been allowed by the web application. And then the response is in red. So that's the query. We can see the SQL injection attack in the URI. And in the response, we get an HTTP 200 OK message, and here's the page that's returned. Now, if we scroll all the way down towards the bottom, we can see down here the data that was revealed under username and password. Now, in fact, in this vulnerable web server, under username, this is the credit card information, and then here is the three-digit credit card code on the back of the card, and here's the expiration date. And you can see there's the next one, and the next one, and the next one. And you can see there are the resulting credit card information, which is listed here under username and password, as well as signature for the dates. Okay, so now in part 2, I'll close CapMe, and then I'll scroll all the way back up to the top of the dashboard here in Kibana, and I'll click on Home to go back to the Home dashboard. Now we're going to examine the DNS data exfiltration. For this, I'll use the same timeline, June 1st to June 30th, and I'll click on the DNS under Zeek Hunting. We'll go to the DNS dashboard. And you can see that we have 22 DNS events, the timeline, the DNS query. You can see here we have a pointer query and a record query. We can see response codes. And if we scroll down here, the DNS client, the DNS servers that were queried, DNS phishing attempts that may register or not. You can see here, phishing attempts. And then we'll scroll all the way down here and notice these DNS queries. So here are the DNS queries. And as you can see here, these queries are all to nsnameserver.example.com. So example.com, once again, this is a test situation, right? This is an example test scenario. So the domain name ns.example.com, but notice the subdomain here. So the subdomain in front of ns.example.com, this does not look like legitimate domain names. How often do you see a subdomain or domain name that has all of these characters in front of it? So this is suspicious. So if we see domain names like this, this should be a red flag to an analyst or administrator. So what we'll do is let's export the raw file, and we'll click here and we can see it's downloaded as dns-queries.csv. Let's open it up, and it should automatically open in gedit. So I have here a text editor, and what I'm going to do is I'm going to just do a quick edit on this file. Notice there are the domain names, and what I'm going to do is I'm going to remove everything but the hexadecimal characters that look like encoding or encoded characters here on the line. So I'll remove all of this, and I'll remove this, and I'm just going to keep these subdomains which look like encoded data. I'll remove the double quotes, and I'll also remove these first two lines. Okay, so now all I have is just the hexadecimal characters here. Notice that the characters all go from 0 to 9, and the largest letter number is represented F. So I know that this is hexadecimal encoding. So I'll save this, and then in the terminal, let's take a look at it and see if we can decode it. So in the terminal, I'll change directories into downloads, and then I'll run the xxd program -r-p, and then I'll say DNS tab, and you can see there it is in double quotes, DNS-queries.csv, and I will redirect the output into a file named secret.txt. Okay, so now if I run an ls command, you can see that I've got a file named secret.txt. Let's take a look at what it says. And you can see, look what it says. Confidential document, do not share. This document contains information about the last security breach. So this is just an example, a test case scenario. Our server was the Metasploitable 2 server that is running Utility, which is a web application for testing web vulnerabilities like SQL injection vulnerabilities or SQL Server vulnerabilities, as well as cross-site scripting attempts. But you can see what happens here is that we were able to decode the DNS queries, and all of those DNS queries were all part of one larger message in a text file. And so using this attempt, a hacker could basically exfiltrate data by encoding that data in a string of DNS queries back to back. And then of course the hacker would need access to the malicious DNS server so that it could then get those queries and then decode them, put them together to access the file, to get the data that has been sent over the network, bypassing the router, bypassing the firewall, and quite possibly bypassing any type of security detection attempts. Now, DNS is one of those protocols that you have to allow through your network. Otherwise, you're not going to be able to resolve domain names. You're not going to have web access or internet access. So this is pretty interesting to see this.